Okay, students. So, in the previous classes, we saw how to analyze beams, cantilever beams, and frames by stiffness method. So, today we are going to see two more problems how to analyze the frames by stiffness method. Okay, so I'm not going to explain these problems in detail. I will just tell you the important things, and remaining things you can fill it up, right? So the first problem is you have a frame with one column and two beams. That means your given frame will be like this. You have the fixed support at one end, a simple support at the other end, or pinned support at the other end, and you have a column having the fixed support at one end, and here you have an intermediate support. So we will name it as A, B, C and D. And you can see, so the moment of inertia for the span AB is 2I, for the span BI is I, and for the span for the column BD is also I. And the length of the span BC is 3 meter. The length of the span BD is 3 meter. And the length of the span AB is, totally it is 5 meter. You have a 12 kilonewton load. Sorry, you have a 10 kilonewton load. 10 kilonewton load acting at an intermediate some point in the span AB. So the distance from A, so the distance of 10 kilonewton from A is 2 meter and from B is 3 meter. So totally AB, the span length is 5 meter. So for this problem, as usual, we will step 1, we will find the kinematic indeterminacy. So the kinematic indeterminacy for this problem is 2. That is rotation at B and rotation at C. So these two are the kinematic indeterminacies. So naturally we will have two system coordinates R1 and R2. Okay, so now we will find the system coordinates. So for that, first of all we will find the force matrix. So force matrix, we have to find the fixed end moments, and also there is a 2 kilonewton per meter. A load of 2 kilonewton per meter is also acting in the span BC. So when we are taking the fixed end moments, see in A, B and BC we have external loads. BD we don't have any external loads. So for A, B and BC we have end moments. Okay, so for A, B and for BC we have end moments. A, B and BC we have end moments. So here there is a 10 kilonewton load, and in BC we have 2 kilonewton per meter load. So the fixed end moments are, since it is concentrated load, we know the fixed end moment at A will be minus, that is anti-clockwise, right? WAB square by L square. So when you substitute, we get 10 into A is 2, B is 3 meter and L is 5 meter. When we substitute, we will get this as 7.2 kilonewton meter. And at the end B, the fixed end moment will be clockwise positive, and the value is W A square B by L square. So substituting, W is 10, A as 2, B as 3 and L as 5. We get 4.8 kilonewton meter. Similarly, for the span BC, your fixed end moment at B will be minus WL square by 12. We will get the value as 1.5 kilonewton meter, and at C the value is plus WL square by 12, 1.5 kilonewton meter. Now we will find the equivalent joint loads. So when we are finding the equivalent joint loads, sorry. So forming the equivalent joint loads, A, B, C and D. So we have the equivalent joint load in the opposite directions, right? So it is a 7.2 kilonewton meter. And at B, here we have a clockwise and here anti-clockwise. So when we subtract, we get 4.8 minus 1.5. We get 3.3 kilonewton meter in the clockwise direction. So here it will be an anti-clockwise direction. 3.3 kilonewton meter. And here it is the anti-clockwise 1.5 kilonewton meter. So while using it for writing the force matrix, we will get it as, sorry, this is not fixed support, pinned support. So we have, see, our degrees of freedom is theta at B and theta at C. So our forces will be the moment at B and the moment at C. So the forces are 3.3 kilonewton meter moment and 1.5 kilonewton meter. Therefore, our force matrix R will be equal to, this is anti-clockwise, right? So we get, so both are anti-clockwise. So our force matrix will be minus 3, 3, minus 1.5, minus 3.3 and minus 1.5 kilonewton meter. So remaining things you all know how to do. So you can find the system coordinate in the third step, element coordinates in the fourth step. Then fifth step I will try to help you. So step 5, see, because the other things we have studied in details in the previous classes. So step 5 is displacement transformation matrix beta. So how will we find beta? We have two system coordinates, right? One at B and another at C. So we will apply unit displacements along the system coordinates. So we apply theta B is equal to 1 and theta C is equal to 1 separately. So when we are applying theta B is equal to 1, so we get, so this is theta B is equal to 1 in the clockwise direction, right? So this is how the deflection takes place, the displacement takes place. Okay, so here theta B is equal to 1. We are applying theta B is equal to 1 and here also the displacement is theta B is equal to 1. Now when we apply theta C is equal to 1, so here clockwise, right? So this is, so this will be like this, clockwise rotation. So this is theta C is equal to 1. So we get the beta matrix as, when theta B is equal to 1, see, we will take this span AB as 1, BC as the second span and CD as the third element. Okay, first element is EAB, second element is BC and the third element is BD. So we get, for the first element it is 0, 1. For the second element 1, 0. For the third element 1, 0. When we take theta C is equal to 1, that is applying unit rotation along the second system coordinate, we get 0, 0, 0, 1, 0, 0, 0, 1. And for BD, we get 0, 0, 0, 0. Okay, so remaining things is as we did in the previous problems. Remaining things, you won't make any mistakes. There is no possibility of making some mistakes in the next step. So I will give you the final answer. So your final moments will be equal to, so your final moments will be equal to minus 7.7184, 3.7632, minus 2.898, 2 into 10 power minus 3. This is approximately equal to 0, right? So minus 0.861 and minus 0.432. So how will we draw the bending moment diagram for this? For the span AB, it is minus 7.71. So it is anti-clockwise 7.7184 kilonewton meter, and at B 3.76 clockwise. So we will get here 3.7632. Now for the span BC, these two values. So at B it is minus 2.898 anti-clockwise. So we will get it as 2.898, and at C it is approximately equal to 0. Now in the span BD, it is minus 8.861, that is anti-clockwise 0.861, and at D also it is anti-clockwise, so we get 0.432. Okay, so one more problem. So in this problem also I will tell you the important things, remaining things you can continue. So next the problem is like this. So if your given problem is a portal frame with a concentrated load in the left support, that is we may take it as 10 kilonewton meter. So the span lengths are 16 meter. You take this as A, B, C and D. See, which means you will have the kinematic indeterminacy is 3 for this problem. That is the displacement at B, displacement at C, and there is a sway. So we will have this rotation at B, rotation at C, that is the displacements are rotation at B, rotation at C, and the deflection at B in the horizontal direction. Okay, these three are the kinematic indeterminacies. So as usual you can proceed, find the fixed end moments and find the R matrix, right? So you will get the R matrix here as 5 minus 20 and 0. See, this 5 is related to theta B, 20 will be related to theta B, and 0 is related to theta C. Okay. So how, okay, here also there is a chance of you to make mistake, that is, see, how did you get this 5? Here we have a 10 kilonewton meter, right? So when you solve this, that is taking sigma h is equal to 0, sigma v is equal to 0, sigma m is equal to 0. Okay, you can take sigma mb is equal to 0. We get, that is the horizontal displacements, HA, right, clockwise. So HA into 16 anti-clockwise minus 10 into 8 is equal to 0. So from which you get HA is equal to 80. So 10 into 8 divided by 16. So we get 5 kilonewton towards the left. Okay. So here we will get a 5 kilonewton reaction for this 10 kilonewton load, and at B we will have, so 10 minus 5 you will have a 5 kilonewton load. That is why you are getting 5 here. This external force is equal to 5. Okay. So these both are reactions. So now you can continue with this. So I will give you the final result. So the final answer is final end moments, right? So the final moments are minus 44.772, minus 5.2442, 5.2498, 11.9096, minus 11.9246, and minus 18.1144. Okay, so thank you. You can solve these two problems today. Thank you.